Good afternoon, everyone. My name is Rajat Boni. I am one of the PMRF research scholar at IIT ISM Dhanbad. Today, I am going to held on geotechnical engineering uh, 2 foundation engineering lecture, which is in week 2, which is taught by Professor Dilip Kumar Vaidya sir in his NPTEL website. So I am one of his TA for this course. So today I am going to discuss here the uh, week two lectures and then try to solve some assignment problems in this session also. And I'm also having some NPTEL experience, previous NPTEL experience, 6 months from July to October 2023 in ground improvement. Uh, and now I am one of the TA of this course, which is the Geotechnical Engineering 2. That means mostly for foundation engineering. So this is week 2, and I am um, give some inputs in about this week 2 lectures and try to discuss the week 2 first. I try to discuss the week 2 lectures one by one. There are 5 lectures, and after that I will try to solve some previous year assignment problem in this session, and also uh, I will give these materials to my Google Drive. You can access uh, these materials, and also I this meeting is recorded. So if I will also share it to my YouTube channel. If you go through it, if you miss something, you will go through it, and uh, we start now our today's lectures. So first we start about week's lectures one by one, then solve some assignment problems. So let's start our session. I'm sharing my screen. Please wait. I think my screen is visible to everyone. Yes, it is visible. So please wait few seconds. So now we start our today's session from lecture 6 in week 2. So this course is in this week we start our uh, foundation properly, foundation engineering chapter properly. So in previous week we discussed about some basic soil mechanics in very quickly, like how soil is created, and also what are the process from where the soil mass is created from rock. That means some pressure. That means the soil is created from different pressures generated in rock masses, and rock masses is disintegrated and create some soil particles. Then we also taught about in previous lecture that uh, how we find our soil properties, like basic soil properties like void ratio, pore water pressure, like that, and also find some engineering parameter like permeability and then shear strength parameter. So we very quick this already we taught this basic soil mechanics in previous NPTEL courses, also in our colleges in basic soil mechanics. And today we start about the foundation engineering. So in our today's class, we discuss about the basic foundation or we introduce the foundation engineering. That means why it is needed and how we will create some one or we can say initiated to create one foundation in the ground to transfer the load. So in week 6, sorry, in week 2, lecture 6, so we first go with some uh, one quotation quotes that the foundation engineering is a applying mechanics, geology, and construction experience to gain insight into how soil response to that civil engineering system can be built and will perform satisfactorily. So here one quotes are given why we need foundation engineering. So actually foundation we design foundation in accordance with the soil condition. How actually the soil behave at a particular situation to tackle this situation we build a safer foundation uh, because we know that the superstructure load of a building or any structure is transferred only through by foundation. If our foundation is weak, then there may be failure of the structure. Even if the structure elements are not is very strong, if uh, that means if our foundation is weak, even if the building structure like a beam column is safe, but due to the weak foundation, the building may be tilted or may be collapsed due to the uneven pressure below the structure. So we have to address all of this by build a powerful foundation system. So then there is some steps are given uh, to for this foundation engineering. So what are the parameter we need to address check before we are going to design our foundation? So here some points are given that first we understand the project and also project site. That means how the project is big or small enough. It is for residential purpose or for some school. We need to address and for according with this we need to build our foundation. Then also develop the design criteria. What are the base parameter? That means we have to maintain. That means we have to some baseline should be there below which we cannot design our foundation. So we need to develop some design criteria. That means uh, for example, for a particular soil, the bearing pressure, that means the load carrying capacity of the soil may be 20. So we have to build our foundation that takes uh, foundation in such a way that the load coming from the structure should not be greater than 20 kilonewton per meter square. So these are like others uh, this. There are many other things to we have to address during our foundation during design of foundation. Then identify the possible foundation alternatives. Like in if you you also know that there may be two types of foundation available. That means different in our uh, construction, there may be different types of foundation, and this foundation is categorized into part. That is, one is shallow foundation, another one is deep foundation. Shallow foundation is means the depth of the foundation is less than equal to the width of the foundation, and deep means if the depth of the foundation is greater than the width of the foundation. So we have to address also by before designing our foundation that whether it is suitable for shallow foundation or for deep foundation. So we need to address. Then also we need to conduct some soil investigation tests like SPT test, standard cone penetration test, or CPT cone penetration test, like this pressure meter test. By this test, we actually understand the actual behavior of the soil. That means how much soil can take loads for a particular projects, and what are the possible hazard in the near area we can identify by this some soil investigation test. Then characterize the site. That means we have to divide the site according to our foundation. That means for that means we have to divide for soil based on the soil strength parameter. That means for if the soil can take better strength, or soil have greater strength, then we go with like shallow foundation. If soil is weak in form, then we go with deep foundation. Like this way we can categorize the site or characterize the site. Then engineering analysis to evaluate the alternatives. Then if we go with shallow foundation for our design, and if we go with shallow foundation, that may not be possible for a particular site, because there may be some voids below the foundation, or there may be some soil which is not suitable for this project. So we need to address this by alternative solution, engineering way. We have to address it. Then develop recommendation and write report, monitor the design, construction, and performance. Then so in foundation engineering, so now we have to understand the project and site. So for this, we have to initiate first to initiate the project by owner, then assess the general soil, site condition, or previous borings, maps, or reports. That means it is based on mainly preliminary survey. That means before going to design our foundation, we have to uh, uh, assess the soil in general way by some previous boring maps, or some reports which is previously exist. Then also some previous experience in the area, that means adjacent structure, how they are constructed or how they were performed. So by looking the adjacent structure, whether these structures are safe, if it is safe, which type of foundations are built or developed for the soil, we have to address also. Then some constants also uh, we have to address. Constants mean we have to uh, look uh, some standards codes. That means we have below which we cannot go. Like some popular code is IS 456 2000. Like this way, many other scores IS 1893 2002 for earthquake engineering design resist building. Then some neighboring facility, whether the access of some raw materials is possible or not. Then economic limitation. We all of this we have need to check before going to build our foundation. Then develop some design criteria. So this design criteria is mainly developed by some experience of this soil or nearby structure. So seeing the nearby structure or some experience or by maintaining some building codes. So first there are some points are mentioned here. That means we need to address some allowable settlement until that means if our structure should not be settled up to that much limit. Settlement um, actually means the movement of any structure due to the gravity into the ground surface. So we have to design our structure in such a way that the settlement should be should not be cross the allowable settlement of which is given in our design codes. For different types of foundation, there may be given different settlement criteria, allowable settlement criteria. If it is crossed, there may be possibility to failure the foundation. Then we also need some factor or factor of safety. This factor of safety actually address the possible, we can say, possible uncertainty we can address by this factor of safety. That means we know that soil is an uncertain material. We cannot uh, tell that what happen in next 2 minutes or next 2 hours in this type of soil. It is very uncertain because the properties of the soil is gradually changing through the soil layer. So for this we need some factors to address these uncertainties. Then identify the constructability issues. So that means if we choose shallow foundation, whether it is suitable for this type of soil or not, we need to check. Then obtain the design load. We need to find out the how much load can carry by this foundation, whether it is suitable. This much of load is suitable for this foundation or not. We need to check. So for this we first calculate the superstructure load and divide the load according to our number of foundation. Then we also maintain some building codes. That means some standard code like IS 456 or IS 1893. We regularly go through these codes, and we have to maintain some standard below which we cannot go with to design our foundation. And it is generalized throughout the country. Then here one figure is given for what is settlement, what is tilt, what is differential settlement. So settlements means if the soil below the superstructure is weak and it is weak uniformly throughout the below the superstructure, then the structure may go down due to the gravity load into the ground surface. This is called settlement. A tilt means if one side of the soil below the foundation is strong and another side of the soil is weak, there may be possibility to tilt or we can say uh, it is go down by angle into the ground surface. So it also may be dangerous because there may be crack along the joints and columns due to this tiltation. And it is similar, it is a differential settlement. It is also similar to this tilt. But in case this differential settlement is occur, it in a one zone of this one or two weaker zone below the foundation. So it also may develop some failure of the structure due to this differential settlement. Now there are some given given some allowable settlement we need to check during our construction for different types of structure. So for office building, the total allowable settlement should not be greater than and 12 to 50 mm. You should remember it is in mm. Unit is in mm. That means if uh, by the importance of the structure, the settlement is going less. If means for we can say if we need a superstructure or building is very important for us, the settlement should be less for this type of building. So for like that, for heavy industrial building, the settlement is about 25 to 75. That means it should be limited in between 25 to 75 mm. For bridges, the settlement should be 50 mm. That means it should the total settlement should not be greater than 50 mm. It is a design criteria for build or constructed foundation. For like for bridges it is 50, for industrial building it is 25 to 75, for office building it is 12 to 50 mm. Then what are the causes? Here discuss the what are the causes for tilt and differential settlement. So there are given that if the soil uh, in both the case tilt and differential settlement is in both the case it is little bit similar. So these are the causes is given here that if the non-uniform soil site is present, that means the pressure below the foundation is non-uniform. That means here is pressure is high, here is low. It is because of the weakness or strength parameter. That means here shear strength is of the soil is very high, so it is stronger. Uh, this region is strong. If the shear strength parameter or shear strength of the soil is weak, it is weaker zone. So due to, but the pressure coming which is coming from the superstructure it is uniform. Okay, it is uniform. So if we apply pressure like this, one side is weak, another side is high, there may be tiltation or there may be occur differential settlement. So these are one cause. Also, the ratio of actual to design load differ about the structure. That means the load coming from the structure is higher if higher than the load which is resisted by the soil, then there may be possibility of the tilt and differential settlement. Again, the ratio of the dead load to live load differ over the structure. That means if uh, one structure is built like this, so live load means this the load which is movable. This is called live load. So if you say one structure is built, which is we call dead load, and if we arrange in such a way that the load the live load in this corner is high and the live load in this corner is low, then there may be possibility in the difference in the pressure. That means here this column is getting higher pressure or this column is getting lower pressure, so there may be also possibility to tilt and differential settlement of the structure. Then built dimension differ from the plane dimension. This means we designer design the structure or foundation for maintaining some category, design category, like we can say foundation like 1 meter by 1 meter. But the builder, which is or worker, by mistakenly it is constructed 8.8 meter by 8 meter. So it is not safe for our design purpose, because we design for 1 meter by 1 meter foundation, but the worker by it is built zero point 0.8 meter by 8 meter. So there may be risks to adjust the load which is coming from the structure. So there may be possibility to fail the structure. We need to address this. Then, uh, what are the effects for when there may be possible differential settlement or occur differential settlement? What are the effects may go? So, if there may be occur differential settlement, the stress in the structure is increased. One side is increased, another side is remaining same. That means if there is a differential settlement like this, the stress here is very high, stress here is very low, like this. Then there may be possibility of cracking. That means we like this way our building is designed. It is foundation, and it is like two-story building. If there may be a differential settlement, that means the foundation below this column is settled and it is remain, and this column is remain same. I can draw it again, can understand better. Say one building, two-story building is there, which is built on two types of foundation, two number of foundation. So if there is differential settlement, that means the settlements occur only uh, occur below this foundation, foundation one or two, I can say. Below the foundation one, there may be possibility to go down this column to into the ground. So and develop some crack at the joints. So cracking may be happening. Also, architectural and structural damage occur due to this stress develop. First, develop the stress, uneven stress develop, then some cracking develop due to this crack. Some structural element like this roof may be collapsed due to this crack. Also, this roof may be collapsed like this or happen in differential settlement. Then in tilt, the structure may be stable, but it structure may be not collapse, but there may be possible uncomfortable feeling may occur. Also, there may be lack of stability of the structure happen. And one famous example is leaning tower of leaning tower of the wall. Here, some previously here in this tower, it tilt occur due to the uneven soil pressure below the foundation, and this may happen. The building may tilt it due to this uneven pressure. Then here it is given design criteria for factor of safety. So the factor of safety is the capacity by demand. So it is the definition of the factor of safety. So for typical foundation, the factor of safety is in between 2 to 3, and for slope and walls, the factor of safety is 1.5. By this, by using factor of safety, we actually reduce our uncertainty of failure. So it is very important for our structure which is designed in the uh, by a material which is very uncertain like soil. So if the material is more uncertain, then the factor of safety should be more. Then some factors are given here for this factor of safety. So the factor of safety is the required reliability. It is based on the reliability. That means acceptable probability of failure. That means by this factor of safety, we address the probability of failure. That means we address the uncertainty of the failure. Then we also address by this factor of safety the consequence of the failure. If we use higher factor of safety, the structure may be safe. If our design may be safe. Then also we address the uncertainties in the soil properties and applied load also by this factor of safety, increasing the factor of safety. Then we also address the construction tolerance like difference between the design and building dimensions. We also ignore the true behavior of the foundation. That means for different type of foundation, the behavior of the foundation is different. So we address by or we generalized by applying this uh, factor of safety. Then benefit ratio, cost benefit ratio uh, for the conservation of the design we can address by this factor of safety. If our cost is more, we have to need to adjust our factor of safety for some extent. Again, it is already I told that uncertainty of the soil properties, which is governs the factor of safety. Then foundation failure are typically costlier than the failure of the superstructure. So we use the factor of safety of the foundation is more, and then construction tolerance in the foundation are wider than those in the superstructure. Then extra weight on the superstructure increases the loads on below the members. So these are the factors which is govern the factor of safety, deciding the factor of safety. Then for design criteria, we have to address the allowable settlement or tilt, acceptable factor of safety, then also identify the construction issues, obtaining the design load and maintaining the building codes. So in now we move with lecture 7 in week 2. So in lecture 7, uh, first to first slide it is also uh, taught in lecture 6. So in second, it is said that identify the possible foundation alternatives. So now we discuss the uh, uh, different types of use why we use the different types of foundation and what are the benefits and potential problems for each types of foundation. So if we design there is maybe possible we can build different dimension of the foundation or different types related foundation and which type of foundation is suitable for what purpose we need to discuss now. So first is here it is given the spread footing. It is one of the shallow foundation, one type of shallow foundation. Here we build one foundation system like this. This is the foundation. This is the foundation. So we build the foundation below each column. So if you build like a one story or two-story building, every column below every column we need to build this type of foundation to spread the load which is coming from the superstructure. So and this foundation should be in reinforced concrete. That means the we applied the concrete along with the reinforcement and it should be below the ground surface or at a particular depth like D. Then there was another type of foundation which is called steep foundation. where the length of the foundation is much more greater than the width of the foundation. You should remember in a stiff foundation or wall type of foundation, or you can say continuous spread footing, the length of the foundation should be greater than the width of the foundation. This type of foundation is called stiff foundation. Then combined foundation or combined footing, we can say this type of footing, it is called combined because uh, if the columns of two columns are very close to each other and the below the foundation, below the column, the foundation area, if the foundation area of each column is overlapping to each other, then this type of foundation may be built. That means if two column is very close to each other, and if we build some foundation below each column, there will be possibility to overlapping of the foundation. So it is better to combine them to carry the load together, and it is more safer than the our spread footing. So this type of foundation is called combined footing. There may be a by geometry. There may be two types of foundation. Combined footing is there. One is trapezoidal footing. Another one is rectangular footing. Rectangular combined footing or trapezoidal combined footing. By dimension only, it is differ. Then now by above this, there are one another type of foundation is called deep foundation. In deep foundation, we mostly use the pile foundation. So here one superstructure is given, uh, 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 almost 8 or 9 story. So for this superstructure, huge load is coming from this superstructure. So to address this load, we need to build the deep foundation. That means we transfer the load in very deep of this ground surface, which may save, which may safely transfer the load from the superstructure through some friction or some engineering of this pile. We uh, we will we will teach or can learn this in our coming session one by one. Now, conduct a soil investigation. So, the most common soil investigation tests are the cone penetration test or expertise test. So, for clay material, the cone penetration test is most suitable, and we can collect the undisturbed sample from the drilling uh, or some field vein and test the soil properties like void ratio, permeability, then uh, friction angle. We need to find out by this cone penetration test. For sand, we use the cone penetration as well as the standard penetration test, and we collect the undisturbed sample. So in cone for clay, collect the we collect the disturbed sample for sand, and for clay we collect the undisturbed sample. You need to remember this. Then so by this soil investigation, we need to determine the engineering properties like engineering index like water content, unit weight, consistency limit, or we're doing some sieve analysis to find the grain size of the soil. Then we also find out the strength of the soil, also find out the consolidation parameter of the soil by this soil investigation. After that, we characterize the site based on the geology of the site. That means field testing and laboratory testing are consolidate the using judgment and experience. Then we also developed a subsurface profile by which we can identify at what depth how much soil is what type of soil is present and how it is behaving. Then identify and estimate the key soil properties. So here one borehole data is given. So we see there at the top layer there is present is gravel soil is present at some particular depth there is present silty sand, and these are the parameters we can find based on the soil investigation only. So so we find by this soil investigation we find these parameters. Then we study the different types of scenario for this soil and what is the best and find out the best suitable foundation type for this soil. Also perform the sensitivity study. That means sensitivity in the sense whether if the foundation is suitable or not for this type of and for different type of you can say different type of situation like sudden earthquake happen like this, whether it is withstand or not like this. Then develop some recommendation or write a report which is based on the liability, cost, certainty of execution and precedence. So at last we monitor the design, construction and performance. So it is now we move to lecture 8. So in lecture 8, it is discussed about the monitor of design, construction and performance. So it is very briefly it is discussed here that in monitoring the foundation is just assessing all your options through the analysis and choosing the best one. That means what are the possible foundation types is maybe possible for this type of soil, and what are the best way and which one is best we have to choose based on our experience or some analysis. Then requires understanding of sites, project, and ability to consider what might go wrong. We also need to address. Then soil mechanics is the tool that help you select, design, and construct foundation elements and the architecture. We These are the points discussed here. Then here discussing the some failure. So failure is a unacceptable difference between the expected and observed behavior. So if we know already that uh, uh, this nature of the material and we didn't expect something from this, then this call is failure. Then now here some general points are given uh, which is irrelevant here. So now we go with the classification of foundation. So we already discussed that foundation is divided uh, based on the depth of the in two types based on the depth of the foundation. So if the depth of the foundation is less than equal to the width of the foundation. That means depth means here I am doing one isolated, or we can say spread footing, and the width of the foundation is, we say, B, and the depth of the foundation from the ground surface, here it is df. If the depth of the foundation is less than equal to the width of the foundation, then it is called shallow foundation, and if not, then it is called deep foundation. So it is said that in the shallow foundation is less expensive, better for lighter structure, or less problematic soil. So, and typical types of the shallow foundation is spread footing, raft mats, or also we go through the combined footing, strip footing like this. And in deep foundation, it is said that it is more expensive and typically used for heavy tall structures and more problematic soil, if we address more problematic soil. And types of the deep foundation is given here is driven piles, drill piers like this. So for most of the residential building, we use shallow foundation because it is the building is uh, shallow foundation because the building load coming from the structure is very light. So, and also most of the residential building is built on the less problematic soil. So we mostly go with the shallow foundation. If our structure is very tall, like more than, we can say, 5 story or 10-story building, then we go, and also the soil is very problematic, then we go with, mostly go with the deep foundation like piles or drill piers. So here it is some factors we need to address when we go with the deep foundation. So if we have more expenses, then, or we can say more money to invest, then we go with the deep foundation for safer foundation system. Also, if the bearing capacity and settlement of the soil is very less, settlement is more, bearing capacity is less, bearing capacity means the strength of the soil is less, and settlement of the structure is very large, then we go with the deep foundation. Also, there may be possibility to present more problematic soil, then it is called then we go with the deep foundation. So now we discuss about the shallow foundation, and we try to develop some equation uh, by which we can find out the bearing capacity for the shallow foundation. So the shallow foundation is transmit the structural load to the soil strata at a relatively shallow depth. So by name itself, it is represents the depth of the foundation is very shallow, and as an approximate criteria, as per the Tarjagi, one of the scientists, which is given most who is given the one equation to find out the bearing capacity of the soil. Uh, for his definition, that the shallow foundation is one which is laid at a depth df not exceeding the width of the footing bf of the footing. So we already I already told you that the if the depth of the foundation is less than equal to the width of the foundation, then it is called the shallow foundation, and this equation or criteria is given by the Tarjagi. So here one picture is given for shallow foundation, which is for isolated footing, and which is also called the spread footing. Now here there are, I mean, other different types of shallow foundation. So here it is given combined footing. Combined footing is if the two column is very close to each other, and the foundation material of one column is overlapping to the foundation of other column, it is better to build combinedly. Then it is called the combined footing. Then if the foundation below some wall or continuous wall, it is called the strip footing or continuous footing or wall footing. Then step footing, if the two foundation is joined by one beam, then it is called the step footing. And last one is mat foundation or rough foundation. This one. So if the number of column is more and the area of this column, foundation area of this uh, each column is overlapping to each other, so it is built combinedly, and this is called the rough foundation or mat foundation. Now here is given the different types of foundation failure. So for shallow foundation, there is three types of failure may occur, which is called general shear failure, local shear failure, and punching shear failure. The general shear failure mostly occur for dense or dense sand and stiff clay. General type of shear failure occur in loose soil, loose sand and soft clay. Uh, the local shear failure and punching shear failure may occur. So in general shear failure, there in a load versus settlement curve, one particular tip may be given, or particular we can say in load versus distribution curve predefined or a possible defined tip may be happen, failure happen, and by looking this curve we can easily say that at this point the foundation is failed. But in local and punching shear failure, there is no tip of failure. So for this, we need to find out the maximum load which is carried by this foundation before it fail in local shear failure and punching shear failure. To find out this, we need to some arrangement, that is double tangent method, and by this we can easily find out the point at which the load at which the foundation is failed. So the here it is said that the maximum gross intensity of the loading that the soil can support before it fail in shear. Remember it, in soil the failure most failure is occur in shear. So if the maximum load which is take by the soil uh, before it fails in shear, this is called the ultimate bearing capacity. This is very important definition of the ultimate bearing capacity. So that means the maximum pressure or intensity the soil can take before it gets fail in shear. We have to remember this. Then one graph is chart is given based on the depth of foundation and the relative density. So it is said that if the relative density of the soil is high, then most of the failure occur for general shear failure. If the relative density is less, that means less than 0.7%, less than zero point 0.7, that means 70%, then there may be a possibility to occur the local shear failure and punching shear failure. Now, now we find out the uh, bearing capacity formula, which is given by the Tarjagi, and we see just look at the we'll just look at the how this formula is derived. we no need for your exam purpose. It is not needed for your exam purpose. You just remember the basic formula, how it is derived. You no need to remember it, but just look at this once, how it is derived. That is, and in this is derived for shallow foundation, and it is given by the Tarjagi, and it is called Tarjagi's theory. So it is derived for the shallow rough. This should be remember. This Tarjagi formula, it is very important for your exam purpose. This line, it is the Tarjagi bearing capacity formula is derived for shallow foundation and also for rough. The foundation's surface should be rough and continuous foundation, that is for steep foundation, and soil layer should be homogeneous and extending to a greater depth. This line should you remember. These are the basic assumption and criteria to develop our uh, bearing capacity formula. And we also remember the different types of failure zone created due to this general shear failure below the surface. So three types of failure zone are created, and below the just below the foundation, one failure surface is called wedged zone. Here, this triangle type failure, and along with this, there's the failure surface is called or failure zone is called radial shear zone. Then the last one is passive zone, and this space the it is this zone is called passive zone because it is act like a retaining wall, which is address the passive earth pressure. So so you remember this zone. There may be three zone. Three failure zone is occur. One is wide zone, then radial shear zone, and last one is passive zone. And the angle of this wide zone is phi. Phi is the this angle is phi. Phi is the angle of internal resistance of the soil, and this zone is act like a passive zone. This is radial shear zone. That means that this surface is fail radially. That's why it is called radial shear zone. And here is apply structure. Structure means the weight of the soil above the foundation. And these are the equations. If we go with the wedges and develop or counter the forces vertically, that is summation of P is equal to 0 or summation of horizontal force also 0, we easily find out this formula. And after that, some arrangement, we can come our final formula, that is QU is equal to CNC plus QNQ plus half gamma V N gamma, where NC NQ N gamma is the bearing capacity factor, which is uh, for yes, NC for cohesion, NQ for overburden pressure or subject, and N gamma for our uh, weight of the soil, for soil weight. And these factors, this bearing capacity factor NC NQ, it is find out based on the angle of internal resistance, that is phi. Based on different value of phi, this and we find out this NC, NQ, and N gamma. And here also given this formula, general formula for NQ, NC, and N gamma. For NQ, it is given this e to the power pi 10 phi into 10 square 45 degree plus 5 by 2. So if you find out NQ first, then it is easy to find out the NC and N gamma, because in both this equation we use the NQ, and for finding out the NQ we need to know the phi value. So it is, this formula is depends on the angle of internal resistance phi of the soil. So we can easily find out this. So here some charts given for based on the different types of angle of for based on the uh, angle of internal resistance of the phi, internal of the soil, that is phi, for different of angle, that is for 0 degree. You should remember this is important. For 0 degree, NC is 5 point, sorry, for 0 degree, that means for pure cohesive soil, the NC value is uh, 5.7, NQ is 1, and N gamma is 0. By increasing the phi, NC, NQ, and N gamma also increasing. So it is mostly depends on the phi. So for in general purpose and general problem, that means for pure cohesive soil, you should remember this value. That is for phi is equal to 0 degree. Pure cohesive soil, the angle of internal resistance of the soil is 0. So you remember this. It is very helpful to solve your problem, many problems. So phi, if phi is equal to 0, NC is equal to 5.7, NQ is 1, and N gamma is 0 degree. Sorry, 0. So now here it is given the above formula, which we have derived by the Tarjagi. It is given for the general shear failure. You remember this? Uh, Hello, Gantha. Hello. Uh, uh, Hello. Are you available, Gantha? Hello.
Good evening, sir.
Actually, the timing of this class is prefixed. It is not changeable. Uh, you can request it to NPTL team to change the timing. I am not do anything for this. Actually, it is fixed for everyone. Uh, so if you have a problem, then you talk to NPTL team. If they ready to change my timing, I can change it for your convenience.
Okay, sir. Thank you.
Okay. So we discussing the bearing capacity formula. That is, mm, so this formula is given for the general shear failure. We already know that there is three type of failure is occur: general, local, and punching failure. So in general shear failure, this formula is derived. So what if there may be possible the soil is loose and occur local shear failure? So we need some adjustment for this formula. So for this we need to adjust our cohesion value and phi value. For cohesion, for both the case we need to multiply 2 by 3, multiply 2 by 3 for both with 2 by 3 with both cohesion and phi. That means for phi we become phi dash. For local shear failure, that is phi dash is equal to 10 inverse 2 by 3 10 phi, where 10 phi is for general shear failure, and c is equal to c dash is equal to 2/3 into c, where C is for general share field. So we need little adjustment if we use this formula for local share failure. And one thing I also told that in local and general share failure, which okay, it is previous slide. Here, here it is. So in general share failure, we find out the predefined failure surface. We can see the failure surface is very visible to in general share failure. In local share failure, and also in general share failure, heaving of the ground surface occur. In local share failure, the failure surface is not predefined or it is not visible. So here there may be for this dotted line may be prefer, and the ground heave also not visible so much. And in punching shear failure, there is no failure zone is created below, only one failure zone is created, and the foundation is punching into the ground surface. So you have to remember this also. So now we coming back to our original slide. So now this formula which is given by the Tarjagi, it is given only for the stiff footing. So what if we use this formula for circular footing or circular, we can say circular isolated footing or square isolated footing. So we need to adjust, our formula little bit. That means this formula is modified for stiff footing. Uh, formula is modified for the stiff footing is for which is applied for the circular footing like this. For circular footing, it is given that 1.3 CNC plus QNQ plus zero point 0.3 B gamma N gamma. And for square footing, it is same thing, little bit changes there, but it is very similar to the circular footing. Only difference is in place of zero point 0.3, it is zero point 0.4. So inside also, if I am rating the ultimate bearing capacity for stiff footing, it is CNC QNQ plus zero point 0.5, that means half gamma B and gamma. So we need to check the coefficients here for circular footing and square footing. In both the case, 1.3, 1.3 present, but in stiff footing, this formula is for stiff footing. There is no 1.3 along with these coefficients, and also it is changed, and in both the all the cases, Q and Q is same, but there is change in uh, coefficient which is along with the n gamma. That means for circular it is zero point 0.3, for square it is zero point 0.4, and for strip footing it is zero point 0.5. So these are the basic difference for these three types of footing. We need to remember this because sometimes there may be happen for mixing up the formula. You need to check every time which type of footing, read carefully the question, which type of footing is there, or ask to find out the bearing capacity, whether it is circular footing, whether it is square footing, or stiff footing. So based on different types of footing, the formula may get changed. You need to remember this. Then there may be modification. Some modification is there. That means for pure cohesive soil or pure cohesionless soil. So we know that in pure cohesive soil, we know that that means in pure corrosive soil phi is equal to 0. So we know that if phi is equal to 0, C is equal to 5.7, NQ is equal to 1, and N gamma is equal to 0. And this two formula is given for the strip footing. You should remember this two formula is given for the strip footing. So N gamma is 0. So if we put all this value in strip footing, then our formula look like this. And if you further modify it like that, 5.7 into C, we put the value NC plus Q, because NQ is equal to 1. And in case of pure quotientless soil, C is equal to 0. So the term C and C get cancelled. The remaining part will be there only. So the formula is look like Q N Q plus half gamma B N gamma. So one problem is there. I think this problem is solved by Professor Dilip sir. So you can go to this video. If you have any problem, I can solve it to the next class. So now I am discussing the last lecture, and uh, which is mostly based on the water table correction. So previously, what I am telling that here, uh, there is no effect of water table. In previous formula, the water table we considered that what we get these three types of formula, we considered that the water table is at greater depth. That means there is no chance to come, the foundation is come to the water table. What if there is presence of water table? So if we know that water is very dangerous for our foundation or for our soil, uh, if we construct uh, uh, some structure on it, the water very dangerous for our construction. So because this the water have buoyancy effect. Due to this buoyancy, the it reduce our strength of the soil due to the pore water pressure, presence of the pore water pressure. So so we need to modify our formula again according with the presence of the water table. So there may be three possible cases happening. One is if the water table is case one, if the water table in between the depth of the foundation. Case two, if the water table is just below the foundation. And case three, if the water table at a depth which is greater than equal to the depth of the foundation plus the width of the foundation. And we find out bearing capacity for all three cases. So in case one, that is if the water table is situated in between the depth of the foundation. It means below the ground surface and above the base of the foundation. So for this, we divide the zone into a one is called D1, another is called D2. In D1, having the having no water table, and D2 have the water table. So we divide our Q and Q. We know that Q is equal to the gamma into dA, or D. We can say gamma into dA for D. So we divide gamma 1 D1 or gamma 2 D2. So gamma 1 D1 is the previously present soil without water table, and gamma 2 D2 is equal to the gamma dash D2. Or gamma dash is the sub unit submerged unit weight of the soil, which is given here saturated unit weight minus uh, unit weight of water. So we easily find, based on this formula, we can easily find out the the modified bearing capacity if water table present. Then case 2. So in case 2, If what in case 2, that if these are foundation, it is called df up to, sorry, it is up to, it is called df, depth of the foundation. Again I'm doing up to this is df from the ground surface. It is width of the foundation b, and from this we can say here it is also width of the foundation is b, and if the water table present in between this below the foundation, but the depth of the water table is not much more greater than the with df plus b. So for this we again modified our formula. So from, if we say from here to here, we can say it is d, small d. So if we modified gamma, unit rate of the soil, gamma dash, by putting by this formula, and gamma bar, gamma bar is equal to the gamma dash plus d by b. Here from at the surface of the foundation to up to the water table, it is called d, and d by b into gamma. Gamma, this means previously present without so so I am telling that if the depth of the foundation, I'm again doing. Hmm. If the water table present at a depth below the below the surface of the foundation is at d, and it is not it is less than the width of the foundation from the below the foundation level, then the our modified gamma will be gamma bar will be gamma dash plus d by b into gamma minus gamma dash, and if we put this gamma bar here, and our formula is modified, and this gamma is the unit weight of the soil without the presence of the water table. You should remember this. So now we uh, try to solve our previous year assignment problem one by one. So first we solve our 2020 assignment problems, and all the notes I will share to you through my Google Drive. So before start with the assignment problems, uh, 5 minutes breaks. I will give 5 minutes breaks. After that, I will start again. So please keep on, stay on the line. I will share. I will discuss again this assignment problems one by one. So after 5 minutes, I will join again. So again, good evening. So now we solve the previous year assignment problems one by one. So first we start with the assignment problem of 2020. So in 2020, there were given assignments about I think for 11 problems. These problems are very easy, and we try to solve one by one. Then, if time permits, we also try to solve uh, uh, 2023 assignment problems. If time remains, if there is no time remains, then I will share it to my Google Drive. So, in 2020, the first question asks that the, a foundation is to be considered as a shallow foundation if the depth of the foundation is the answer is the less than or equal to the width of its width. The option is B. The correct option is B. We know that the Tarjagi is given that the shallow foundation is equal to if the depth of the foundation df is less than equal to the width of the foundation B. So our correct answer is option B. So uh, in question 2, it is asked about the combined footing. So we know that the combined footing is that type of footing if the two columns are very close to each other and the foundation material of these two columns is overlapping, then we combinedly build. So here we need to check which option is go with is closer view of our combined footing. So option B is tell that the number of columns is 2. That means it is correct, and they are placed close to each other. It is also correct. So our correct option is option B. Then in question 3, it is asked for the ultimate bearing capacity of a surface strip footing on clay, and according to the Tarjaki theory. So it is said that find out the ultimate bearing capacity for surface strip footing. So our formula is on clay. On clay means our phi is equal to 0. If phi is equal to 0, Nc is equal to 5.7, Nq is equal to 1, and N gamma is equal to 0. So in strip footing, we know that the strip footing ultimate bearing capacity is equal to Cnc plus Qnq plus half gamma b n gamma. So we know that it is rest on the surface. So our Q and Q will also become 0. We know that Q is equal to gamma into df. Here df is equal to 0. There is no depth of the foundation. So it is also 0. So remaining part is Q, bearing capacity Q is equal to CNC. And NC value is given here is 5.7 for Tarjaki. So it is become 5.7 C. So our correct option is option A. Then it is said that if the square footing of size 4 by 4 meter by 4 meter, you should before solving the problem, you should go with carefully go line by line and try to underline the keywords like square footing. Then resting on the surface of a clay is given. That means phi is equal to 0. Resting on the surface means df is also become 0. Then it is given the unconfined compressive strength is about 44 kPa and need to find out the ultimate bearing capacity based on the Tarjagi's formula. So it is given for the square footing. So we know that in square footing the formula is 1.3 CNC NQ QNQ plus zero point 0.3 I think I have to check. Has point, sorry, point 4. Point 4 Q and Q, Q and Q plus point 4 gamma B N gamma. So it is told that pure clay. So we know that in pure clay N gamma is equal to 0. So this pass cancel out. And also it is told that resting on the surface. So is this pass also cancel out. The remaining part is 1.3 C and C. If you put all this value 1.3 into C, the value of C is given here. There is not given, but it is said that the unconfined coefficient is given 44. So we know that C coefficient is equal to the half of the unconfined coefficient strength. So if you put 44 here divided by 2, it is become 22. So our C is 22, and then if you put here ultimate bearing capacity, Q is equal to 1.3 into 22, that means C into, we know that for phi is equal to 0 degree and C is equal to 5.7. So it is become, we calculate it. I also calculate here my sheets solutions. It is become 163. So correct answer is C, option C, 163. Then in question number 5, it is asks for what is the Tasdaq is bearing capacity factor NC, NQ, and gamma are the function of what? So we know that it is the function of angle of internal friction only, because we know that NQ is equal to the e to the power pi tan phi into tan square whole into tan square 45 degree plus 5 by 2. If you know the NQ, you can find out NC and also N gamma. So it is only depends on the angle of internal friction, that is phi. So our correct option is angle of internal friction, that is option B. Now here, now we solve the question number 6, and it is asks to find out the footing size. It is very tricky problem. So please understand the problem first. So it is said that square footing, and it is said that general shear failure. So two term is given, two keywords is given also, and also tell that cohesionless soil. So C is equal to 0. We consider. Then ultimate load is given. Q ultimate is 380 kilonewton, and also tell, also given here, depth of the foundation is 2 meter, and gamma is given uh, 17 kilonewton per meter cube. Q is given 41.1, N gamma is given 42.4 to find out the size of the footing. So we know that the ultimate load is given. So we need to find out the ultimate bearing capacity. So we know that Q ultimate load is equal to the ultimate bearing capacity into the area of the footing. That means if it is said the square footing, we said that the width of the or length of the footing is B. So the total area is B square. So and we also find out the Q ultimate. So in Q ultimate for square footing is 1.3 CNC plus QNQ plus zero point 0.4 gamma B N gamma. So we know that for questionless soil, C is 0, for this part is 0, the remaining part is there, it is here. I also solve here, you can see, and the unknown part is B. If you put all this value in this equation and try to solve the cubic equation, because here one is B is given, here also one B is given, and put all this value, we find out and try to solve this cubic equation. So we find out that B is equal to 0.49 meter. And I think to solve this problem, we need the scientific calculator. It is not possible for us to solve this problem by hands. So you need scientific calculator for this solving this problem. And we find out that this the width of the foundation is 0.49 meter. It is very important problem and very tricky problem for your exam purpose. So you need to go with you have to go with this problem. Now we solve question number 7. Try to solve question number 7. So in question number 7, it is given that two circular footing of dimension d1 and d2 are resting on a surface of a purely cohesive soil, that is phi is equal to 0. The ratio of the d1 by d2 is equal to given 2, and the ultimate bearing capacity of the footing of diameter d1 is given 200 kN per meter square. Then the ultimate bearing capacity of footing for diameter d2. So it is very simple problem. So we know that for circular footing the formula is given C 1.3 C N C plus Q N Q plus 0.3 gamma B N gamma. ठीक है. Okay. So for pure cohesive soil, we know that N gamma is equal to 0. So this part is equal to 0, and it is also resting on the surface of the ground surface. So Q and Q also 0 because dF is equal to 0. So remaining part is Qu is equal to 1.C and C. So if you clearly see that this formula, the ultimate formula, is not depend on the uh, width of the foundation, or you can say diameter of the foundation. So for foundation 1 or footing 1, the value is given 200, and this same value also taken for the footing 2. So our option is, so both the case the ultimate bearing capacity is same. So our option is option B. Then in question number 8 of our problem, so in question number 8, it is said that a strip footing is given and width of the footing is given 1.5 meter and the depth of the foundation is given 1 meter, resting on a dry sand. So we can say in dry sand C is equal to 0. So then the ultimate bearing capacity is given for strip footing is 17. We have to find out ultimate bearing capacity of this strip footing, and given here this gamma is 17 degree, sorry 17 kilometer per meter cube, and phi is 38 degree. And from Tajik theory, Q and Q and N gamma is given, which is 60 and 75. So So it is very easy. So we know that for questionless soil, steep footing, the formula is QU is equal to QNQ plus half V gamma N gamma. If we put all this value, and we will get the answer is 1976. I already solved here. You can see that I put all this value, gamma is equal to 17, DF is 1 meter, and then NQ is 60, then half gamma also again 17, B is 1.7, 1. Sorry, 5, and N gamma is 75. So our answer is here it is 1976.25. So the closest option is here is 1976. So our correct answer is option B. Now we try to solve question number 9. So in question number 9, here it is said that the ultimate bearing capacity of the square footing of plan dimension is given 2.5 meter by 2.5 meter resting on the surface. So these are the keywords: square footing, resting on the surface, then also uh, given the ultimate bearing capacity as 300 kilonewton per meter square. When the water table is far below the base of the footing, this ultimate bearing capacity given for when the water table is far below the ground surface or footing. And when the water table, we have to find the ultimate bearing capacity when the water table is at a depth at a depth of 3 meter from the surface. 3 meter is at a depth of 3 from the surface, and the ultimate bearing capacity we have to find. Your given gamma dry density of the soil is given 17, gamma saturated is given 20 kilonewton per meter square, and gamma W is given 9.81 kilonewton per meter square. So we have to first draw the diagram, decide the square footing, and resting on the ground surface. So like this, our foundation, and it is said foundation width is given 2.5 meter, and the water table present is at 3 meter below the ground surface. So we can directly see that the depth of water table is greater than width of the foundation. So there is no water table effect present to find out the ultimate bearing capacity. So the same bearing capacity which is for uh, when the water table is at a greater depth is apply here also. So our correct option is option A, which is 300 kilonewton per meter square. Then in question number 10, it is said that for the footing in the problem 9, that means it is related to the problem 9, when the water table rise to the base of the footing, the ultimate bearing capacity of soil. So we need to find out our ultimate bearing capacity when the water table rise to the ground surface. That means the water table comes here. So first from question number 9, we again it is analyzed further. It is given the square footing, but pure question square footing for pure questionless soil. I think it is given sand deposit means questionless soil C is equal to 0. A square footing. So we can write here 1.3 CNC plus QNQ plus zero point 0.4 B gamma N gamma. So C is equal to 0. So 1.3 CNC part is 0. So remaining part is Q NQ plus zero point 0.4 B gamma N gamma. But again, the foundation is resting on the surface, ground surface. So Q and NQ is 0. So remaining part is zero point 0.4 gamma B N gamma. Here gamma is here gamma dry density. So if and Q is given 300, so zero point 0.4 gamma D is given here 17, and width of the foundation is given 2.5. So by this formula we find out the N gamma. So after finding the N gamma, we put again use the for uh, same formula, but the gamma will be modified, and gamma D is become gamma day, that is unit weight, subgrade unit weight, submerged unit weight of the soil. So gamma dash is, we know that gamma dash is equal to the gamma saturated minus gamma W. So gamma saturated is given here 20, and gamma W is given here 9.81. If we put all this value, we find the gamma dash, and put again this formula gamma dash B n gamma. So if you put all this value, n gamma already find in previous equation. Before all value, we find the answer is 179.75. So I also solved here in very short way. You can see here rest at the surface, questionless soil, no water table effect. If then we find out the N gamma is 17.65. After water table at the base of the foundation, the modified it is become gamma D become gamma dash this, and if we put all this below, the answer is 179.82. So the correct option is here option C. Now we find out uh, our last question of our session, which is question number 11, and it is very important for with respect to the correction of the water table. To find out the ultimate bearing capacity when the water table presence below the foundation level, but not um, uh, in between below the foundation level, but at a depth which is less than uh, the width of the foundation from the foundation level if the water table is present. So for this, sir will is given or discuss one formula here in the last lecture, which is given here. This formula, we need this formula to solve this last problem of our assignment. So if here we modified our gamma into gamma bar, and this formula is we need. So now first discuss the problem, and then I discuss the solution. So it is said that, hello. So now it is said that the a 2-meter wide stiff footing is located at a depth at a 1 meter below from the ground surface. The subsoil consists of a uniform deposit of medium sand, dense sand. The field and laboratory test results are as follow. The angle of internal friction is 33 degree. Then saturated and dry unit weight of soil is 19 kilonewton per meter cube and 17 kilonewton per meter cube. Then the unit weight of water is 10 kilonewton per meter cube. Then ultimate find out the ultimate bearing capacity of the soil when the water table is at a depth 2 meter below the ground surface. So, and given NC, NQ, and gamma is given for phi is equal to 33 degree. So first understand the problem. So here it is given that a foundation is present at a depth below 1 meter from the ground surface. So the depth of the foundation is 1 meter. Gamma DF is 1 meter. Width of the foundation is given here is 2 meter. I think yes, 2 meter. And the water table present at a depth 2 meter below the ground surface. So from the ground surface, the water table is at a depth of 2 meter. Up to this is 2 meter. So 1 meter is here. So remaining part is 1 meter. And so we can see that this 1 meter is less than 2 meter. So there may be presence of water table effect. So because we know that if uh, the width of the foundation, depth of the water below the foundation level is greater than uh, is greater than the width of the foundation, so there may not be any water table correction. So if it is present, then maybe water table correction is applied. So for this, we need to find out first gamma bar. So gamma bar is the gamma plus D. That means depth of the water table from the foundation level by B, width of the foundation, divided minus gamma dash. So gamma dash is again here is sub gamma dash means gamma sub, or you can say gamma dash is equal to the gamma saturated minus gamma W. I think I have to look at it once. Yes, it is here one correction. It is gamma dash. Okay. So put all this value here. Gamma D is 1 meter from the foundation level. B is 2 meter. Gamma is given here is 19. Sorry, gamma is given here is 17 because uh, above the water table the soil is dry. So here water table it is gamma D. Below the water table is gamma saturated. So gamma is here is gamma D. Put 17 and then gamma dash. If first find out gamma dash, put here and find out the ultimate gamma bar and put this all this value because it is positive for putting. We use same formula q c n c plus q n q. Q is here gamma df plus half gamma bar b and gamma because it is pure sand. So c is equal to 0. So put all this value, you find out that the option is D, 963.13. I am also solving here. It is, we can go through it. So as of now, I close my meeting here. So I uh, also given you, I will also given you in my Google Drive the 2023 assignment problems. You look at once and try to solve these assignment problems by yourself, and also solve the assignment problems which is given in the Nptel website in your portal. You go through once, and if you have any doubts, you can ask me in the next class. I will try to address you. Uh, and also, this session is recorded and I will share it to my YouTube channel. You can look at if you have missed any concept, and for I will meet you again in the next week. As of now, I close my session. So best of luck, and we will meet again. So good night. I am now closing my meeting. Thank you.